Okay, now we are with the question number 3 for the week number 7. And once again, we're going to have a spool, but this one is going to be quite different from the one we had earlier. This one is not going to be fixed in the middle. Actually, it's going to be supported by two rollers on the side, the roller A and this roller B. Still have the center of the gravity to be in the middle at the G. You can see that this diameter is 200 millimeters. The outside one is, I think, well, let me see the other diameter, 800 millimeters. Okay, we have the mass of the whole spool is going to be 250 kilograms. So the weight is going to be 250 times 9.81 Newton. We have the cable here with the p-value of 400 Newton and with the angle that's shown by this triangle. The spool is supported by the two wheels, which are going to be separated by 30 degrees from the left and the right. So the free body diagrams show me that the weight is going to go downward, and these two forces are going to go upward with the angle of 30 degrees from the center G. And we have this one. So we have three forces now. The spool cable originally is at rest. The mass of 250 kilograms and the radius of the gyration kg is equal to 350 millimeters. If this spool rests on in two small rollers A and B and a constant horizontal force P of 400 Newton applied to the end of the cable. Compute the angular velocity of the spool when 2 meters of the cable had been unrevealed. Neglect the friction and the mass of the rollers and unrelieved cable. So we just need to find actually the omega. Once again, this spool will rotate for, this will actually extend for 2 meters. That means that the P force multiplied by 2 meters distance for is displacement to find the value for the U. Okay, so you understand that, right? The point at the end of the cable is going to be extended for 2 meters because said that the cable is going to move for 2 meters. That will be one of the U equations we're going to have. So the solution is just a free body diagram is going to be drawn first, and only the 400 Newton force do the work that I told you about, 400 multiplied by 2. And then the equation is going to be equal to T1 plus the U1 to 2 sigma is equal to T2, and we know that this one now is going to be just the 400 multiplied by 2. So we will show you that now. The T1 and the T2 should be found, and obviously that the T1 is going to be equal to 0 because the omega 1 is equal to 0. So we just need to find an equation for the T2 as a function of the omega to find the omega to be equal to 7.23 radian per second. So we come once again to the free body diagram. That's the free body diagram. We have the forces and A and B, and we have the weight going in the middle and the P going to the side. The kinetic diagram is going to be something like 2 meters. I should sketch actually 2 meters for the point P to move within. That's 250 kilograms. Kg is 0.35 meters. The P is 400 Newton. Omega 1 is 0, and the S, displacement, is equal to 2 meters. Unknown is the omega 2, and the equation going to be the same. Okay, so in its movement, we're going to have the omega going in that direction. The moment here going in the same direction. Now we're going to start to do the calculation. First, I can find the moment, right? Yeah, I can find it. Anyways, let's go to the equation. The T1 is plus the sigma of the U1 to 2 is equal to T2. The T1 is 0. The T2 is half Ig omega 2 square, and the Ig is the m k g square. Now I know what the value of the kg, I know what the value of the mass, but I don't know what the omega 2 is. So I can write down the equation in terms of the omega 2, and this will give me that the omega 2 is equal to, sorry, the T2 is equal to 15.3 multiplied by the omega 2 square. So that's good. I found at least the T2. And now I need to find the value for the T, the sigma of the U1 to 2. We know that the work is equal to the force multiplied by displacement. So the sigma of the U122 is going to be equal to 400 multiplied by 2, and this will give me 800 joule. Straight as that. Okay? All other external forces do not work because the spool is not going to go up and down. So now we know the value for the sigma U1 to 2, and we know the value for the T2. Put that in the equation. We find the omega is equal to 7.23 radian per second. And this problem cannot be solved using the conservation of the energy because the force P that does not work is not going to be is not actually a conservative force in this scenario.